Good morning, good afternoon, good evening, namaste, salam alaikum. A very warm welcome to Questponds YouTube channel. And today we will be learning SQL query basic writing step by step, lesson by lesson, SQL by SQL in flat 1 hour. So in this 1 hour, we will see that you can at least end up writing decent SQL. Now SQL, which stands for Structured Query Language, is a very important topic, and for any programmer or an IT professional, good SQL query writing is a must skill to have. So what I'll be doing in this 1 hour of tutorial is I'll be writing 30 SQL statements, which covers select, update, insert and delete operation. And I can give you a 100% guarantee that once you are done with these 30 statements, you should be in a good position to write decent SQL. Now, for this tutorial, I am using SQL Server as my RDBMS. So in case you are new to SQL Server, then you can please go to this tiny URL and you can at least get started with SQL Server so that, I'll be going to the TSQL window, I'll be right clicking and so on. So I will not be teaching SQL Server basics, right? So in case if you are new to SQL Server, please go to this URL so that you can get the basic understanding of SQL Server. And yes, I have recorded a lot of such videos on my website questpond.com. So whenever you have time, please do go and visit the website. So let us get started. Now all these 30 SQL practice labs are based on an invoice database. This invoice database is nothing but it has a customer database, a customer table, which says that this customer has bought which product, what is the cost of the product. It also has an address table and so on, right? So you need to go and run this practice SQL file out here. This practice SQL file, you can get it from questpond.com or you can get it from if you are playing this video out there, right? In whichever place you're playing this video out, on that video at the top or at the left hand side, you should get this practice SQL statement. In case you don't get it, please mail me on this ID out here. I will help you out to get this SQL file. So you need to go and open this and execute this whole thing. And with that, you can see now at the left hand side, the invoice database has been created. So this invoice database is on which we will actually be going and practicing these 30 SQL labs. Also, let me explain you what this invoice database has. So this invoice database actually has like 9 tables, around 9 tables, right? And let me explain you the structure of these tables and what exactly these tables do, right? Like in the video also I have explained it. Like, so when you're writing the SQL, I will re-explain the tables, but still let us quickly have a overall look on what kind of tables are existing in our invoice database. So first thing, the main table here is the TBL product customer table. So this TBL product customer table has an entry of which customer has bought which product of which model and at which date. So you can see that we have a customer table. So this customer table has entries of all the customers, and if a customer buys a product, he will have an entry in the product customer. You can see that we have a product table. So whatever product is bought, again, that is entered into the product customer. And for this product, which is the model, is also entered from the TBL model. And for every customer, for the customer, we can have one or many addresses. So you can see again, there is a one-to-many relationship between TBL customer and address table. I have also created one product backup table. I'll tell you why I've created this. This TBL product backup table backups the data from the TBL product into this table out here, right? Also, we have a TBL ancillary table. What is this ancillary table? So let us say that you have a product called as t-shirt. So with that, you can go and buy some ancillary other products called as, let's say, cricket kit or a football kit. So if you buy a t-shirt with a cricket kit, you will get some discount. So these ancillary products are, products, which you can buy at a discounted rate with the main product. So the main product is in the TBL product, but the ancillary has those extra products, right? And then we also have a TBL country and a TBL area table, which says that this model is manufactured by in which country and in which area. So basically, we have these 9 tables out here. TBL product customer, which is the heart of everything. It has an entry of which customer has bought which product on which date of which model and which ancillary product is associated. Every customer can have one or many addresses. We also have a product table which is having the products which are sold. We have a product backup table to take a backup, right? So this is basically the base database on which we will be practicing our SQL. So ensure that this database is created. In case you are having any problems, please mail me at questpond@questpond.com. I will be more than willing to help you to create this database so that you can start practicing. So now let us get started. Let us get started with SQL practice 1. So let's start with the first SQL statement. Select all the columns of a table and select all the rows of a table. Now I would suggest that because you are started learning SQL, I would suggest that for the first 1 or 2 months, type SQL manually so that you can learn it properly. So rather than using this thing in SQL Server, rather than going and right clicking like this and saying select everything, this gives you a ready-made SQL. What I would suggest is always open up a new query window and start typing it out here. So with this, you will learn SQL in a more better way. So do not use the ready-made IDE for the first time to write the SQL statement. So let us start with the first statement. Select all the columns and all the rows of a table. So the select statement starts with the word select. So that is a command. You can see the time when I type select, it has made the color blue. So that indicates that our syntax is right. The next thing starts is the column names, which columns you want to select. So I will say star. When I say star, that means that I want to select all the columns and then from which table name. For example, at this moment in our database, we have TBL customer. So let us go and say TBL customer and let us fire this. So with this, you can see that I'm able to see all the columns and all the rows of my table. Now, definitely it is not a good practice to select all the columns of a table because depending on scenarios of an application, you probably need 3 columns or 4 columns or 1 column. So if you write star, that means that you are selecting all the columns and the data is just getting transferred from the SQL to the application unnecessarily, right? So as a good practice, always try to put the column names here. So for example, I can say, I want to just fetch customer name and I want to just fetch customer phone number. So there it is. So if I now execute, okay, that's a good error. You can see now it says invalid object name TBL customer. Why? Because at this moment I have selected the master database. The master database belongs to SQL Server. So it's a system database. So I need to go and select the invoice DB. I have to be inside the invoice DB to fire this statement, right? So you can see from here, I've changed to invoice DB and then I'll say execute. So you can see now, I can see that only customer name and customer phone number is selected. Now, let us say you want to go and you want to select a specific record. For example, over here, let us say I want to go and select a specific record that is 1 or let's say 4, right? So for that, we need to go and specify the where clause. So the where clause syntax is as follows. You will say select column names from table name where customer ID is equal to, let's say 3. So if I fire this, you can see now he has selected just the record 3. Now the where clause again has 2 flavors, when it comes to equality check. If it is a numeric data type, you will say customer ID equal to 3. But now let us say I want to select by customer name. Now customer name is a string data type. It is a varchar or nvarchar or something, right? So for that, I have to give here customer name, but I cannot give Shiv like this. I need to give it inside a single quote. So I need to give it inside a single quotes like this. So you can see now single quotes. So remember, if it is a string data type, then you need to give it inside a single quote. If it is a numeric data type, you can just say equal to and the number. Now please note that Shiv has 2 records out here. So that's why it has fetched 2 records. So one record is the customer ID with 1 and the other record of Shiv is having customer ID as 7. So there are duplicate records in the table. Now you can also go and specify a AND condition or a OR condition. So to specify an AND condition, you can use the AND operator, and to specify an OR condition, you can use the OR operator. So for example, now you can see that I have duplicate records here. So let us say I want to select only customer ID with 1 Shiv, right? So I can say here AND customer ID is equal to 1. So with this, what will happen is he will only select the first record, right? So if I execute this, you can see it is selecting the first record, right? And if I say, okay, customer ID is equal to 1 or equal to 7, then I will get 2 records, right? So you can put a OR condition or you can put a AND condition. So you can see now it is selecting customer ID where it is equal to 7 as well as customer name where it is equal to Shiv. So AND condition and OR condition. We can use the order by clause to sort the records in ascending or descending order. So first thing, by default, it is always an ascending order. For example, you can see when I just say select all the records from the customer table, it is all ascending. But if I want to go and make it descending, I can say order by, and then depending on which column you want to make it ascending or descending. So for example, I want to use the customer ID and I want to make it descending. So DESC. Now please note, like as an important tip, if the syntaxes go wrong, then they are not in a blue color. For example, if I make a mistake like this, you can see that suddenly it gives it as a black color, right? A black color can be an entity name like table name or column name. So that means that something wrong is over here. So remember that whenever you see blue signs, that means your syntax is proper. So at this moment, I am trying to say here, okay, order by customer ID, but descending. Descending means I should see 7, 5, 4, 3, 2, 1. So there it is. And also you can go and you can sort using multiple columns. So you can say, okay, do a primary sort on the customer ID, but also use customer name for a secondary sort. So if you want, you can specify multiple columns in your order by clause, right? So you can see now primarily it is using both of them to do the descending, right? And if I make it ascending, there it is, right? You can also go and use the alias feature of SQL. For example, at this moment, you can see that on the display, I am seeing customer ID, name, and phone number. What if I want to go and put some more user-friendly names here like ID, name, phone, right? So what I can do is I can say here as ID, as phone, sorry, as name, and as phone, right? So by giving an alias, this will actually give a user-friendly name to my columns. So if I execute this, you can see now the column names have changed to ID, name, and phone. If you want to go and select distinct records, for example, let's say that we go and we select customer name here. So if you remember, customer name had duplicate records. So for example, you can see in the customer name, I have Shiv and Shiv. So I can go and I can put a distinct over here. By this, I will just get, you can see that the duplicate Shiv has gone. So when this distinct was not here, we had duplicate Shiv record. You can see Shiv here and Shiv. But when I put distinct, I can only see one Shiv, right? But please note that distinct applies on the whole column. In other words, if I go and put customer ID out here, you will see that he has also shown Shiv. So you can see why, because Shiv 1 and Shiv 7 are different records for him. So actually when he applies distinct, he applies on the whole row and not on a specific column. Sometimes we want to go and we want to search using a pattern. For example, I want to go and get all the records, wherein the name starts with S. So for that, we have something called as wildcard operators in SQL. So what we can do here is we can say here, for example, you can see at this moment, I have 8 customer records, Shiv, Raju, Shyam, Khadak, Rajiv, and so on. But I want to get only those records, wherein the name starts with S. So I can go and say here where customer name. So this is wildcard operator like. And so I want to go and search all the records by S. And then after that, you have to put a percentage sign. A percentage sign indicates that any number of characters and any characters after this will be valid. So I should see Shiv, I should see Shyam, I should see this Shiv, I should see Sam and Sim, right? So let us go and execute and let us see. So you can see here, I am seeing all the records which is starting by the letter S. And also please note that you can always go and put the percentage sign at the start as well, right? So you can say, okay, get me all the records, wherein it starts with anything but ends with S. Oh, okay, we don't have anything, but for example, this one will give me Shiv, Rajiv, and Shiv. So you can see he has fetched all the records, wherein it ends with the letter V but starts with anything. A lot of times, we want to search in between of the pattern, in between of the letters. For example, I would like to say that, okay, get all the records which starts with S, with ends with M, and should have and can have any one letter in between. So you can see here, I'm saying here, get me all the records which starts with S, ends with M, but it can have any one letter. You can see I have just put one underscore. So that one underscore indicates any one letter. It can be A, B, C, D, or even a number if you want, right? So when I execute this, you can see I'm getting Sam and Sim. But if I put one more underscore, that means two letters. So then I will not get any record, right? So an underscore indicates that any letter, any one letter in between. If you put two underscore, that means two letters. So percentage underscore. Many times we want to go and we want to find a particular letter or not find a particular letter. In other words, for example, I want to go and say that get me all the records which starts with S. So I can say here like this, S percentage, right? So this will give me all the records which starts with S. I'm sorry, like, remember, you cannot use that word equal to now. In order to enable pattern, you need to use the word like. So this gives me all the records which starts with S. But what if I want to say that no, now give me all the records which does not start with S. So for that, you need to go and put this into a square bracket like this. So now you can see here, it shows all the records which start with S. But if you wish, you can go and you can negate it. You can say that no, now get me all the records which does not start with S. So there it is. You can see now it is showing me all the records which does not start with S. And please note that you can always go and use all the combinations like this, percentage, underscore, square brackets, to form any kind of pattern. So basically, wildcard operators use the like keyword and helps us to do pattern searching. A lot of times, we want to go and we want to create a runtime calculated column. Runtime calculated column means a column which is calculated on the base of the field of a table. For example, you can see here we have product ID, product name, product cost. So you can see that I've queried a table called as TBL product where we have the product cost. Now let us say I want to go and I want to create a discount column, a discounted column which will use this product cost and it will subtract it by 50, right? So what I can do is I can go and I can put a simple arithmetic here. I can go here and say, so this is product cost minus 50. So you can go and put any arithmetic out here and this will go and create a field here, an extra field here, or extra column. I will say this is a runtime column which is using this product cost minus 50, which is 150, 300 minus 50, which is 250. And you can see that we do not have a column name here because we have not put an alias, right? So if I put a discount here, you can see now it is showing a column name as well. So if you want to go and create a runtime column, right, you can go ahead and you can write the arithmetic equation and then put an alias. A lot of times, we want to use a case statement on a column. For example, I want to do something like this. I want to go and say here that if the product cost is above 100 and below 200, then I would like to display that product cost is medium. But if the product cost goes above 201, then it is a high product cost, right? So I want to go and display string values, and I want to, rather than showing the numbers, I want to show something else. So in this case, you want to go ahead and put some kind of a if statement or a case statement here, right? So you would like to say here, okay, case, if the value is between 100 and 200, it is a medium cost. If the value is above 201, it is a high cost. So for that thing, you can go and you can use a case statement here. I will go and delete this discount out here. So I can go and say here case, let me expand this, case. So when product cost is greater than 100 and product cost is less than 200, right, then say medium cost, right? And if the product cost goes above 201, so if it goes above 201, then show high cost. And also I can say like else, let's say if it is none of them, then I would say that just display do not know, right, or NA, right? And please note that you have started with a case, you have to end with a case, end case, right? So you can see now I have written here a case statement, case, ends, end case here, and then say when this, then display this, when this, then display this, right? And now this becomes uncalculated kind of a column, a runtime kind of a column. So you can see that I put a comma here as well. So product ID, product name, must be, you can give a nice name here. You can say that this is as rating, or I'll say as cost level, right? Cost level, it is high or it is low, right? Let me go and check the syntax here. There are some errors. What is the error? So we can see query completed with errors. Let's execute this. Incorrect syntax. Okay, so else must be, it is just this case. Let me check this syntax. Okay, it is just and. I'm so sorry for that. I do a lot of VB script as well. So when I do VB script, you need to write end case over there. Okay, so end, fine, right? So there it is, command completed successfully. That means we can check the syntax. Remember, in SQL, you can see this small question mark out here, this small correct mark out here, sorry. This helps you to check the syntax of SQL. Sometimes when we are working on production server, firing SQL means it is very resource intensive. For example, in one of our previous companies, there were like millions of records. So if you fire an SQL statement, it goes ahead, it does a lot of processing at the back end. So if you don't want to go and fire the SQL and check your syntax, you can just go and do this. So with this, without firing the SQL on the database, it checks the syntaxes. So specifically when you're on production, you want to be pretty sure, you probably would like to use this small thing out here. So I can see the command is there, so I can execute this. Now you can see here, okay, you can see it is showing NA because it should be less than 201, isn't it? So there it is, or must be, I should say, equal to. Okay, so you can see now this first one, 200, it is between 100 and 200, medium cost, it is about 200, it is 201, it is high cost. So you can go and you can use this case and when statement if you want to go and create columns, where you want to put some conditional ifs and then show some value. Many times we want to go and club two result sets and make one result set. In other words, for example, you can see that in my database I have two tables out here. So one is I have a product table. Please note, you can always go and drag and drop like this. And the other one, you can see I'm writing a Go here. What a Go does is it actually goes and fires multiple SQL statements on the SQL Server Management Studio. And you can see multiple result sets down below. For example, you can see now I'm firing two SQL statements out here. One on the TBL product table and the other on the TBL ancillary table. So if I execute this, you can see I can see two result set windows out here, right? Remember, these are two different result sets. Please note, they are not one result set. So this is the first select statement result set is this. The next select statement result set is this. Okay. But now I want to go and take both of these tables and create only one result set so that it can be displayed. So we have a product table here, which has products. We have an ancillary product. Ancillary product means which supports the primary product. For example, he can buy a shoes and he can also get a cricket kit. He can buy a shirt and he can get a football kit, right? So basically I have an ancillary table and a product table. So if you want to go and club two result sets or two tables, you can go and you can use union all or union. So I can say union all. So you can see now it has gone ahead and it has taken both the results and it has joined them together. Now please note, it is not necessary that to make a union you should be selecting from different tables. Means, for example, I can go and I can make a union on the same table as well. So you can see over here now I am making a union on the same table. So this is also possible, right? So union all. So you can see now shoes shirt and shoes shirt again, right? So you can go ahead and you can make a union of two result set and make one result set. So that's what this union keyword is all about. But now there are a couple of rules around using union. The first thing is that the column names, the number of columns of the first select and the next select of the union should be same. Means, in other words, over here, for example, I will say, okay, select product ID and select product name. Okay, or let's say let's select product name and let's select product cost. Okay, product cost. And over here I have ancillary name and ancillary cost, right? So now here the number of columns should be same and they should also be of the same data type. So you can see here this product name is string, ancillary name is also string. The product cost is money data type. The ancillary cost is also money data type. So now if I execute out here, you can see now this works. But in case if let's say that if I have only one column in this table and two columns from the top union, then this will probably give me an error. Oh, it did not give me an error. But it also did not make a union, you can see. Let me check that. Oh, there it is. That's what I'm wondering, that how it did not give me an error. So you can see now, I don't know what happened previously, but you can see definitely the number of columns should be same on the both sides of the union, right? So it should be ancillary and ancillary cost. And second, the data type. For example, if by chance, if I go and if I put this like this, then again, this will not work. This will say that, oh, the data type is mismatching. You can see it is saying that this isn't care and this isn't money. And I don't know how to do things, right? So the number of columns should be same and the data types of every column, respective columns, should also be same. Now this union syntax again has two flavors. For example, you can see here, when I do a union all, it actually also shows me duplicate records. For example, you can see there is shirts 300, which is coming from TBL product. And there is again shirts 300, which is coming from the ancillary table, right? So when I do an union all, it also shows the duplicate rows. But if I just do a union, then I would see only one shirt record out here. Watch this. So if I say execute, you can see now I'm only seeing only one record. So union all displays duplicate records or duplicate rows, while union just displays unique rows. When you talk about fetching complex data, then definitely you will end up fetching data from multiple tables. So in other words, you will have two tables or three tables from where you will fetch the data, make some joins and get the final result set. So for that, in SQL Server, they have given four kinds of joins. One is an inner join, second is a left join, right join, and a full outer join. So let us try to understand all the four joins. So first thing what I will do is let me go ahead here and select two tables. Now we have a TBL customer table. So this is a TBL customer table. And also we have one more table here called as the TBL address table. So this TBL address table stores the addresses of the customer. So you can see out here, we have two tables out here. One is a TBL customer table and the other one is a TBL address table. So this customer table stores the addresses of the customer. And the join between both of these tables is made by this thing here called as customer ID. So this customer ID is a foreign key to this primary ID of TBL customer table. So you can see here, this Shiv's address 1 is Mumbai. You can see Raju, which is customer ID 2, is Mumbai. And you can also see that I have put some addresses, which is not assigned to one customer. And you can also see over here that there are some customers for which there are no addresses in the address table, right? So now let us start with the first type of join, inner join. Now inner join helps us to fetch matching data from two tables. So for example, over here in this TBL customer table, we have Shiv and Raju who has addresses in the address table, who has the addresses. But Sham, Khadak, Rajiv and other guys don't have address in the address table. So it will only fetch Shiv and Raju and the corresponding address from the addresses table and no other record. So the records which are not matching are not fetched in the inner join. So in order to write an inner join, the syntax is like this. So select star from the primary table, that is the customer table, inner join on inner join address table. And what is the key? The key is that from the customer table, from the TBL customer table, this customer ID should be matching with the TBL addresses customer ID. So remember that the join between both of these tables is done by this column here, customer ID, with this column here, customer ID, right? So you can see the syntax here, select star from the table name, that is TBL customer, inner join. Inner join means you want to get only the matching records, inner join on the table TBL address. And what is the criteria? Where the customer ID of the customer table matches with the customer ID of the address table. So let us go and execute this, and you can see here he has fetched only two records. So Shiv and Raju were matching. He just fetched Shiv and Raju and their corresponding address. So this is termed as the inner join. Now let us take the next scenario. Let us say that you want to fetch all the records from the customer table, either they are matching or either they are not matching in the address table. And from the address table, you want to only fetch the matching records. So if you see in your SQL at this moment, let me just expand this. If you see in your SQL, the way the syntax is written, TBL customer inner join on the address table. So that means at this moment in your SQL, the placement of the customer table is on the left hand side and the placement of the address table is on the right hand side. So now what you are saying is you want to get all the records from the customer table, matching or not matching, and only the matching records from the address table. So in that case, you will go and you will say left join. When you say left join means in the SQL, whichever is the left table, it will fetch all the records from it, matching or unmatching, and from the right table, it will only fetch the matching records. So if I go and execute this, you can see that from the address table, he has only fetched the matching records, right? While if you see from the customer table, he has fetched customers, who even don't have an address. You can see that a lot of these customers did not have an address and it is showing null, right? And the right join is opposite of the left join. So for example, if you say, I want to get all the records of the address table, it is matching or not matching, and only the matching records of the customer table, then you will just go and make it as a right join. Remember, left and right is from the perspective of the SQL. In the SQL, whichever table is written as left becomes a left table, whichever table is written on the right becomes a right table. If you go and if you swap these table names here, then they will become opposite, right? So at this moment, when I say right join, that means from the address table, that is the right table is the address table, it will fetch all the records matching or not matching. And from the customer table, it will only fetch the matching records. So you can see here from the address table, he has fetched addresses which are unknown, which are not assigned. And from the customer table, he has not fetched customers who do not have addresses. So only the customer who have addresses he has fetched. So left join and right join helps you to fetch records matched or unmatched from the left or the right table and only the matching records from the other side. Let's take the next scenario. Let us say that you want to show all the records from both the tables. From the customer table and address table, you want to show all the records, either they are matching or either they are not matching. And wherever the records are matching, you would like to go and show them together. And wherever the records are not matching, you would like to show it as null. So for that, we have something called as a full outer join. So what you can do is you can go and you can change this to full outer join. And if you execute this, you can see here that he has shown all the records of the customer table, right? And also he has shown all the records of the address table, either matching or not matching. And wherever the records are not matching, for example, for the customer records, wherever there is no address, he has shown it as null. And for the address record, wherever there is no customer, he has shown it as null. So the full outer join actually helps you to fetch the matching records as well as the unmatching records from both the tables, and also ensuring that wherever the records are matching, they show it in a proper one row. A lot of times, we want to get a result which is a Cartesian of two tables. Cartesian means every row of one table gets combined with all the rows of other table, like a Cartesian product, or you can say like a permutation and combination. For example, think about it. In your shop, you have some primary products like shoes and shirts, and you also have some ancillary products. Now these ancillary products, you would like to offer it with the primary product to the end customer. So the end customer can buy shoes with a cricket kit and he will get some discount. He can buy shoes with a football kit and he will get some discount. He can buy shirts with the cricket kit, he will get some discount. He can buy shirts with the football kit and he can get some discount. So in other words, now really what you want to do is you want to take the main product table and take every row of the main product table and multiply it with the ancillary table, right? So in other words, you want to create the combination, permutation and combination of all the rows of both the tables. So for that, you can go and you can use the cross join. So you can say here cross join on cross join table. There is no on here. There is no criteria of equality because every row will be just combined with the other rows, right? So with TBL ancillary table. So here now I can say from the product table, select the product name, right? And from the ancillary table, let us select the ancillary name of the product. So ancillary product name, ancillary name. Okay. Right. So you can see now, this is a cross join. Okay, so let me go and check my syntax first. Okay, looks like everything is good. Now you can see here, he has taken shoes and made a combination with cricket kit. He has taken shirts, made a combination with cricket kit. He has taken shoes, made a combination with football kit. And what you can do is, so you can go ahead here and also display the total. So you can say that, okay, the total is TBL ancillary cost plus TBL product cost, right? So basically, and again put an alias here. By putting an alias, it will give you a nice user-friendly name. So I'll just put an alias here as actual cost, right? So you can now see that basically it has taken both the products and the total is out here. Now I can go ahead and put some discount here. So I can say, okay, this is the actual cost, but because you are buying both the products together, I would like to give you a discounted cost of, let's say, -50, right? So this is my discount cost. So you can see here, because of this cross join, so that's the discounted cost. So you can see 300 is the actual cost when you buy both the products together. But because you are buying both the products together, I'm giving you 50 discount. So now that we have completed like 30 minutes of tutorial, it is now time to go and write an SQL, a complex SQL, by using all that what we have learned. So we have learned union, we have learned union all, we have learned the different kind of joins. So it is now time to go and write a complex SQL. So if you see in our database, this TBL product customer is the heart of all the database. In the whole database, this is the table where the actual sales is noted down. So in this table, we have a customer ID which says that which is the customer, who has bought the product. We have the product which this customer has bought. We have the model for that product, and we have the sales date on which this transaction happened. Now what I want you to write on simple SQL where you will display the customer name, you will display the product name, you will display the product cost, and the date on which that sales happened. So in other words, we need to go and make an inner join with the customer table. We need to make a join with the product table and display the data. So let us see that if you can do this yourself. It is very important to test yourself. So try to attempt this yourself. So go ahead and pause this video and try to attempt it yourself. In case you are not able to do it, no worries. After some time, I'm going to go and show you how to do it. But I would suggest that be honest, pause it and try to attempt it yourself. If you are able to do it, that means you are understanding SQL. Or else I'll be explaining you how to go ahead and show the customer name, the product name with the product cost and sales date. So I hope that you have attempted it yourself. In case if you have not attempted it, you can see what I'm going to do out here. So what we want to display the customer name. So first thing is we need to make an inner join with the TBL customer table, and the join will be on. So the join will be on and let us start putting alias over here, because this can become very complex. The big names can become very complex when we are putting the join criteria. So we can say this TBL product customer, we can name it as PC. This we will name it as C, right? So we will say now where PC dot. So the product customer ID underscore FK inner join table on PC dot, where PC dot customer ID underscore FK is equal to C dot customer ID, right? We also would like to get details from the product table. So we also need to make an inner join on the product table as well. So again, inner join TBL product table. Let's name this as P. So PC for product customer, C for customer, right? On C dot customer ID is equal to P dot customer ID, right? So let's go ahead and check the syntax. It looks to be good, right? So now we want to display from the customer table, we want to display the C dot customer name. From the product table, we want to display the P dot product name. We also want to display the product cost, right? So P dot product cost. And we want to display the sales date from the product customer table. So P dot sales date. So let's check the command. You can see that command is all okay. And let's go and execute this. It's saying that the customer ID is not found. So basically, let's look at the table. So TBL, we have customer ID here. What about the PC, the product customer? On the product customer, what is the column name? It is customer ID underscore FK. So that is also right. What about the product? Let's look at the product. So in the product, we have, I'm sorry, this is my mistake out here, and it is good that we are making mistakes. This product table has to be joined with the PC dot, this is not on the customer ID, right? I'm so sorry for this. So this will be PC dot product ID underscore FK. I'm so sorry for this, product ID underscore FK, right? And we will join it with the product ID. Remember that the product customer table is joining with the product customer table is joining with the product table using the product ID. So that's why you have to give here the product ID. With the customer, it is the customer ID. I'm sorry for this. So now let's go ahead and let's execute this. So there you can see, I can see the customer name. I can see the product name from the product table. I can see the customer name from the customer table. I can see the product cost. Also, I can see the sales date on which this sales happened, right? So basically whenever you are writing complex SQL, you will end up in such kind of inner joins and left joins and right joins. So normally when you look at a complex SQL which is running on production, right, you will find that it is very huge. It is having the case statements, it is having union, it is having inner join, it is having a where clause, and so on, right? So good. If you have attempted it yourself, congratulations. If not, then try to please understand what I've wrote here. Great. So now let us say you want to go ahead and display that how much sales has been done for a particular product. For example, if you see your shoes, we have sold shoes 4 times, 1, 2, 3, and 4, and the total is 200 plus 200 plus 200, that is, and 200, 800. While shirts, it is only 300. So in other words, I want to go ahead and display the total sales made per product. So what it means is that you want to go ahead and group on a product, on the product name. So group by p dot product name. So in other words, you want to go ahead and group on the product name. So once you put a group clause, you cannot use the other fields. For example, if you try to use the customer name, it does not make any sense, right? Because you can see here that shoes is bought by Shiv also, and shoes is also sold by Raju. So bought by Raju, right? So in other words, it does not make any sense that when you put a group by clause, you cannot put the other fields other than the group by clause. For example, if I try to execute this, it says that TBL customer is not valid in this. Why? Because it is not a part of the aggregate function. So in other words, here, whatever group by clause you have put here, I have to put the same group by clause, same fields at the top of the select. So I cannot put those fields out here, which is not the part of group by. So I will go and execute. So you can see now it is just showing search and shoes. So once now this is grouped completely out here. We need to now go and put aggregate functions like sum. For example, I want to go ahead and display the sum of the product cost, total sales, right? So I want to go ahead and display the total product sold. So you can see now shoes has been sold, total sales is 800, and for shirts it is 300. You can also go and put down count. So in other words, whenever you use group by, you can now go and say, okay, count. I want to also display the count as number of items sold, right? So with this, I can see now that shoes has been 4 items had been sold. So per 200 is 800, while shirt has been sold for only 1 item has been sold, and that is 300. So by using the group by clause, you can go ahead and you can group by a particular field, and then you can apply on that aggregate functions like sum, count, average, and so on. So first rule for the group by, whatever field you put in the group by, you can only select those fields in the group by, and the other fields or other columns can only be aggregate function like sum, count, average, and so on. So you cannot put over here customer name, because that does not make any sense. It is not a sensible thing to put a customer name, because customer name can be attached with multiple products, right? So group by helps us to group an item, and then we can apply on that item mathematical formulas like sum, count, and so on, aggregated formulas like sum, count, average, and so on. One more important thing which goes with the group by is having. If you remember in the previous part of the video, I had explained that if you want to put a filter, you can use the where clause. Now the where actually filters on the row level. So like for example, on a table, it will apply the filter. Okay. But if you want to apply filter on a group level, then you have to say having. So for example, I'll say having count, which is greater than 1. So in other words, I want now to go and see the total sales, but only of the products, whose sales has happened more than once. So that means that it should not show shirt here now. It should only show shoes. So having clause helps you to apply filter on the whole group which comes out by using the group by clause, while the where clause applies filter on a particular select statement. So for example, if I do on select here, you can see now it is showing the value as only shoes, right? So having clause applies filter on group by, whereas the where clause applies filter on a particular select coming from a table. Like for example, here I can say on this, and then I can say where PC dot customer ID. Yes. So anything which is a part of group by, like sum, count, it has to be a part of having. I cannot do like this. I cannot say here where count star. That would be difficult. It would throw me exception. So the where clause is applied on the individual table fields, while the having clause is more on the group level. Till now, whatever examples we have seen of inner join, left join, right join, cross join, and so on, we have always referred to different tables, two different physical tables. But there are a lot of scenarios, wherein sometimes we have to refer the same table. That means doing a self-reference. For example, you can see a typical scenario here. You can see that this is the data of TBL customer. In this, I'm displaying the customer ID. And also I have something called as customer reference ID. This customer reference ID tells that this customer was referred by whom. For example, you can see customer ID 1 is Shiv. And then we have 2 Raju, and you can see the value 1 here. So this says that Shiv referred Raju. This is again 1 Shiv referred Sham. 3 Sham. Sham referred Khadak. So basically this reference ID out here says that who has referred that customer. So in other words, in this table, the primary key is customer ID, and in the same table, customer reference ID underscore FK is the foreign key. And wherever you see the values null, that indicates that this is a direct walk-in. In other words, nobody has referred him. So now let us say we want to go and display the customer name, and we want to go and display who has referred him. Now this is a typical case, where you want to make a join, either inner join or a left join with the table itself. So the first thing is you need to go and put a qualifier here, an alias. Why? Because you're going to go and refer the TBL customer twice, right? So select star from TBL customer name, inner join TBL customer T2, self join. Self join means joining to the same table itself on T1 dot customer reference ID underscore FK is equal to T1 dot customer ID, right? So here we will display the T1's customer name and will display T2's customer name. Let us see what output we are getting. So you can see now I'm making a join on the customer reference ID. So wherever we have customer reference ID, I'm making an inner join, and let us see what we see. Inner join on T1 dot customer ID is equal to T2 dot customer ID. You can see I've set both T1, right? So you can see now Raju is referred by Shiv, Sham is referred by Shiv, Khadak is referred by Sham, Shiv is referred by Rajiv. Now remember, Shiv has duplicate records, huh? So you can see this Shiv is not this Shiv, please note. And Sam is again referred by Shiv. Must be we can go and say that this is the customer name and this is referred by. So with this, we can put an alias so that now things are looking good. So Raju is referred by Shiv, Sham is referred by Shiv, right? You can also see that we have missed some records. For example, we don't see Sim here. Why? Because it is an inner join. So in other words, whoever has the reference ID, only those are seen. But we would like to go and see everyone. So for example, if we have Shiv, he does not have a boss. Let us try to, he does not have a referred by, but let us at least say that, okay, that he is a walk-in, right? So for that, we need to go and make a left join. In other words, select all the data from T1 and wherever you find customer ID, display the referred by ID, right? So with this now, you can see Shiv is a direct walk-in, it is null. Rajiv is a direct walk-in, it is null. And Sim is a direct walk-in, right? So with this now, wherever there are null, that means that this indicates it's a direct walk-in. So self-reference is used, when you want to make a join, either it can be an inner join, left join, right join with the same table itself. Now you can see that this referred by is null, which does not look good, right? So rather than showing nulls, can we show like direct walk-in? Because these are direct walk-ins, right? These are not referred by any other customer. So you can go and you can use the is null function. You can say here is null T2 dot customer name. So it'll say, okay, if this customer name is null, then go and display direct walk-in, right? So when I execute this, now you can see Shiv is a direct walk-in, Rajiv is a direct walk-in, Sim is a direct walk-in, but other people's have a referred by. One more important concept in SQL is a subquery. A subquery, as the name says, subquery, in other words, it's a subordinate query. So in SQL, we can have nested queries, and one query output can be fed to the other query. So for example, now let us say we have this TBL customer, and we also have TBL product customer. So in TBL product customer, we have all the customers, who has bought the product. Now let us say I want to go and display those customer names who has bought product from me, who has done some sales from me. So some of the customers, like Khadak and Rajiv, has not bought anything, so they do not have entry in the TBL product customer. So what we can do here is we can go ahead here and write a subquery. So here I can go and do something like this. I can say where TBL customer dot customer ID in select TBL product dot customer ID. You can see now this is a nested query. In other words, here first this query will be evaluated. The output of this query will be fed to the outer query. So you can see this is a subquery, and the output of this subquery is again fed to the input of the outer query. And you can have a lot of such kind of nested queries, right? So here I can go and say TBL customer dot customer name. You can see that I'm using aliases everywhere because a lot of fields names are same, right? So we can have ambiguity. So if I say execute here, what is it? Select TBL, incorrect syntax near TBL. Yeah, the where spelling is wrong. Let's correct it. So you can see now Shiv and Raju has only bought the products and other people have not bought the products, right? So this is a subquery, a nested query, you can see. Like basically the output of this query is fed again to the topmost query. And again, you can have one more select query here, outer query if you want, right? And the output of this query can go to the outer query. So you can have lot of such kind of nested queries. One more important concept in SQL is the correlated queries. It's an important concept as well as it is complicated to understand. Let us try to understand the scenarios in which correlated queries can help you. For example, now see this situation here. You can see that I have a product table, and in this I have 5 products. So we have caps, we have socks, we have shoes and shirts and pants and so on. And I can have 100 such kind of products. Now let us say you want to go and find the product whose cost is the second highest or the third highest from it. So let us say that I want to go and say that, okay, which is the second highest? Then the second highest is shirts. Or if I say, okay, get me the fourth highest, then the fourth highest is socks, right? So for such kind of scenarios, correlated queries helps you a lot. So what is a correlated query? A correlated query looks like a subquery. So it has an outer query and an inner query. But, as compared to one subquery, the correlated query has a bidirectional kind of nature. In other words, in correlational query, what happens is first the outer query gets evaluated and passes the values to the inner query. Depending on the values of the outer query, the inner query then evaluates and gives the data back. So here it is more bidirectional. And if you remember, in case of subquery, it is more unidirectional. So let us see that how we can solve this problem by using correlated queries. So in this case, first, so over here we will say select product name and product name from TBL product. Now remember that again over here I need to go and make a self reference. So let's start putting aliases TBL product as T1. So this is the T1 dot product name, right? Let me first write the query where count star, or I'll say rather where, let us say I want to find the second highest, is equal to, I pasted something. you can see here, I'm saying that find me the second highest. First, let's execute this and then I will explain it. So let me execute it, and you can see out here that shirts is the second highest. So it is showing shirts. Remember, the below window is the output of this query. The top window is the output of this query, right? So you can see it is shirts. If I say that this is, let me get me the fourth highest must be, then he will probably show me socks. Yeah, the fourth highest is socks. That is right. What I was wondering. Okay. And if I say, okay, get me the first highest, then the first highest is pants. That's right. Okay, I'm sorry. I was thinking something else. Okay, so you can see that this query is working and it is an correlated query. Let me explain you. So you can see that I have said here T1 is the outer table, right? And then I'm saying select count star from T2 where T1's product cost is less than the T2's product cost. So what happens now? First, he will go and he will take, let us say he will take 50. Let us say I want to find the first highest, right? The top one. So it will take caps. It will take its product cost of 50, and he will say, okay, how many products are greater than 50? So he says, okay, there are like 5 products greater than 50. 5. So is 1 equal to 5? No, he just leaves it. He goes to the second sock. So he says, how many products are greater than socks? 100, right? So he says 1, 2, 3. Oh, so again, 1 is not equal to 3, right? So in this way, you can see he takes the value T1, passes it to the inner query. The inner query evaluates it and then again passes it back. So there is a to and fro communication between the inner query and the outer query. So this is termed as correlated queries, correlated subqueries. So this, you can see, like, this is a very favorite example. When you, I've seen that in interviews, a lot of people ask that find the second highest salary or find the third highest salary. Then the way to approach that problem is by using correlated queries. Now we want to go ahead and find from this product table. You can see that we have this product table here, and this product table has certain products with product cost. We want to find the maximum product cost, the minimum product cost, and the average of all product, right? So for that, we can use aggregate function straightforward. We can say here, select max of the product cost, right? You can always put an alias, say that this is the maximum cost, right, of a product. Minimum product cost as the least as the cheapest product. So this is the cheapest one, right? And then average. So average is by AVG. You can see how the IntelliSense is also working out. Product cost as overall average. So by using the max, mean, and average, you can find out that across your product table, which is the maximum product cost. You can see 700, the cheapest one product is 50, and the average is 270 across all the products. Now let us say that you want to go ahead and find out the product cost which are between 100 and 300. So there are two ways of doing it. One is, remember, we had the where clause. So you can go and you can say here that product cost which is greater than 100 or equal to 100 and product cost which is less than or equal to 300. So with this, it will actually give you the products, which are between 100 and 300. You can see here, right? You can always go and put an order by clause. Nobody stops you. Order by product cost, so that you can see the results in a more better way. So there you can see he has fetched the products between 100 and 200. This is one way of doing it. Or the other is you can just use the between clause from product, where product cost between. So this is again a better way of doing it. Nice syntax, between 100 and 300. So this will also give you the same results. So between is a better way of doing it because it makes your syntax more easier to read. Lot of times we want to take a data from a table and dump it into a new table. So for that we have the select into syntax. So we can say select star into the new table name. For example, I'll just say TBL1 from, let's say, TBL customer. So what this select into syntax will do is it will take the customer table and create a new table of the same structure and dump the whole data into TBL1. Now, because I have said star here, it will dump all the columns. But if I want, I can go ahead and just say customer name. It will just dump customer name. Also, if I want, I can go and I can put a where clause here. I can say that, okay, where customer ID is equal to 1. So it will just dump one record. So for now, let us try to go ahead and dump the whole TBL customer into TBL1. So I'll just say execute. You can see that he has said here 8 rows transferred. So if I go and refresh my database, you can see that over here at the left hand side, there is a new table created, TBL1. And if I go and see the records of this table, you can see that all the records from TBL customer has been transferred to TBL1. So select into syntax helps you to create a new table and dump the records from one table into this new table. A lot of times we want to go ahead and get the top 1 or the top 2 values from a given record set. For example, you can see that I have fired this select star from TBL product and it is now displaying to me like 6 records. But now let us say for some reason I want to just go ahead and show only the first 2 records, right? So what I can do is I can go here and say top 2. So if I say top 2, it will just show me the top 2 records. And if you combine this top 2 with a descending or ascending order by, you can get the top 2 minimum values or you can get the top 2 maximum values as well. For example, you can see now it is now displaying to me top 2 minimum values. But if I want to get the top 2 maximum values, what I can do is I can just say order by product cost descending. So if I do this, you can see that it is now displaying to me the top 2 maximum values, right? So the top clause, the top clause helps us to slice a record and say that you want to get the top 2, top 3, top 4 records from a given record set. So till now, we have only looked into select queries. Now let us see that how we can go and also insert data. So let us look into insert syntax as well. So here is our TBL product table. It has 3 fields. So let us say we want to go and add a new data out here, a new product out here, like let's say tie, right? So the insert query starts something like this. Insert, it starts with the insert syntax, insert into table name. So what is your table name? TBL product, and followed by the field name. So the fields are, we want to insert product ID, we want to insert product name, we want to insert the cost of the product. So you can see we are providing the cost of the product, product cost. Now for each one of these field, what values you want to insert? So values. So for product ID, we have till now the product ID 5. So we're going to go and insert 6. So the product name is tie. Now you can see here, this is a string, right? If it is numeric, you will say without a single quotes. If it is string, then you will say with a single quotes, right? And again, this is numeric. So let's say the cost is 200. You can always go and first check the syntax just to ensure that everything is right. And you can go and say execute. So now if you go and fire the select query, so if I now go and say, if I now go and see the table, I should see, you can see that tie has been added to the TBL product table. A lot of times we want to do a bulk insert from one table into another existing table. So for example, now you can see here, I have this TBL product table, right? And also I have one more table here called as the backup table. So this backup table is actually empty, product backup, right? So you can see that the product table has records. It has 6 records, while the backup table does not have any record. So now let us say that you want to go ahead and import data from this table into this table. In other words, you want to do a bulk insert, Must be that is a good name for it, right? So the table is existing. Remember, we also covered the select into syntax. In the select into syntax, the table does not needs to be existing. It auto creates it. But here the table is existing. So for this, we can go ahead and again, we have a variation of the insert statement. So we can say here, insert into TBL product select, sorry, into TBL product backup, I'm sorry. And from where do you want to insert? You want to insert from TBL product. Now you can see here, over here I'm because this has 3 fields and this has 3 fields, right? I can just take all the 3 fields and import it here. But sometimes, the destination table can have only 2 fields. So what you can do is you can always go and say here that, okay, insert into TBL product backup. I want to only insert product ID, and from here only select product ID. So you can actually go and choose columns if you want, right? But for this, at this moment, let's do like this. Let us go ahead and import all the data. And please note that this select clause out here can have a where condition. It can have union. It can have union all, so all that select, whatever we have learned till now, you can put all the variation of the select out here. So let us go ahead and execute this syntax, and you can see now the backup table has the records, right? So basically, if you want to do an insert, bulk insert into TBL product backup, and then write the select clause. So the whole select data will be imported from that table into the destination table. So from the source table, all the data will go into the destination table. And please note, again, I repeat, you can always put a where clause, you can always put union, you can always put inner joins. Nobody is stopping you from that. Now also this insert has a variation. For example, let's say that your table has 3 fields, and if all the fields you are going to insert, right, then what you can do is you don't have to provide this field name out here. For example, I can go and I can straightforward say here 7, and let's say this is a bag and the cost is 1200. So you can see now I'm not providing the field name because all the 3 fields I'm providing data. But in case if you are not providing all the field data, then you need to go and specify for which field this corresponding values data is. But this should also work. You can see it has inserted 1 row, and I should see my bag inserted into the TBL product. Also, let us try to understand how we can go and write an update query. So let us say we want to go and update this second record out here. We want to update the shirts value to t-shirts, and we want to update the product cost to, let's say, 500. So for that, the update query goes as follows: update table name. So our table name is TBL product, right? And what do you want to set? I want to set the product name to t-shirts, right? T-shirts. And I want to update the product cost to, so I want to update the product cost. You can see I put a comma out there, product cost to 500, right? Now please note, do not hit update. If you hit update, all the product name will become t-shirts, all the product cost will become t-shirts. So always remember that, put a where clause. In case you are on production, this can be a mess, right? So be very, very careful when you fire the update or the delete syntax. Always put a where clause. So we'll say here where the product ID is equal to 2, right? So let me go and fire this statement. Now you can see here in this TSQL window, in this SQL management window, I have 2 SQL queries. One is the select part and one is the update part. I can go and I can select a specific query and I can say execute. So with that, only this query is now executed. So you can see here our update SQL has been executed. And let us say if you want to go and see if the update has happened, you can go and select only this thing and say execute. So you can see now the update, the row 2 has updated. The row 2 has been updated to t-shirts and the product cost is 500. So the syntax of update is update the table name is TBL product, and then say set, and then start setting the values, whatever you want to set, and the where clause. Please note, always put a where clause. If you don't put a where clause, the whole data of the table will become t-shirts and 500. So we are done with insert, we have done with select, we have done with update. Now it is time to go and delete a record. Now small things, what you can also do is, in your query window, you can always go and comment some of the SQL. So you can see here I selected this and I commented it, and you can also uncomment back. You can see this small thing out here, comment, uncomment, right? So let us go and comment this update, or else it will keep updating the data for no reason. So to write the delete syntax, it is as follows: delete. Now remember, delete is a very a sensitive statement, so you should be very careful when you're using it, right? So delete from table name TBL product. Now remember that if you do not give any where clause, it will go and delete all the records, which definitely you don't want, right? So let us say I want to go and delete the 7th record, that is bag. So I can say here product ID is equal to 7, right? So I can go and I can first do a check syntax out here. Yep. And I can say execute. So there it is. One record has been deleted. I can just say execute here. You can see the 7th record has been deleted. Now remember that in the update as well as in the delete, in the where clause, you can put all the things, what you can put in your SQL. In your SQL, remember, you can put a wildcard, you can put an AND clause. So whatever you can do in your select where clause, you can also do in your delete and update as well. So here I can go and say where product name, like, remember wildcard operator, I can say percentage and I can say S. So it will actually go and delete all the records, which has S in between, right? So that was the delete syntax. It is always a good practice to go and write SQL manually, because when you write manually, you exactly know which tables you are selecting, you exactly know which columns you are selecting. But when it comes to large applications, which have hundreds of tables, 200s of joins, it is sometimes very difficult to go and write things manually. You want to quickly get started and get all the tables and the fields and the joins, at least the basic structure together, and then you would like to go and change it, right? So first thing is, whatever I'm showing at this moment, do not try to use it. In case you're new to SQL, do not use it in the first 15-20 days. Try to write SQL manually, try to practice so that you get good hands-on in SQL. But once you are all set and comfortable with SQL, then you can go and you can use this thing here called as the query designer, design query in editor. This is nothing but this is a wizard in SQL Server Management Studio, which helps you to go and create your query using a designer. As I've said, in case you're new to SQL, avoid this so that you get good hands-on on SQL, or else what will happen is you will become a slave of this editor, right? So try to understand what this editor produces rather than depending on this editor by itself. So I can go and say, let us say I want to go and select, what products were sold and who bought it, right? So you can see now I have selected 3 tables. One is I have selected the product customer, and then I have selected the product and I have selected customer. And you can see automatically he figured out the foreign keys and primary keys. And you can see that he has automatically made the joins out here. Now I can go and I can say, okay, take customer name from here, take customer code from here, take product name, product cost, and then take the sales date from here. And then when I say, okay, you can see that he has given out a proper, nice, ready-made inner join to me, on which I can work. And you can also see that he has also used proper aliases. So you can see this is TBL customer, inner join on the product, right? And inner join on product on TBL customer, this and this, and then inner join on this, right? So you can see how basically he has created this whole SQL, right? So you can see everything is created in a minute. And we are all ready and set. So I can go and I can fire this, and there it is. But as I've said that do not try to use the designer at the first. Try to first try to do things yourself, try to write the SQL yourself. But again, this is a very important tool. At least when I'm working on maintenance projects, where I have big tables, it is very difficult to go and write all these table names and field names. At that time, I definitely rely on the query editor. I get the base SQL from the query editor, but later on, definitely I change it. I put things manually and I see that I get the best SQL out of it. So that brings us to the end of this session. So what we will do is after this, I'm going to go and flash a questionnaire slide. You can go and you can try to answer those questions yourself. If you can answer those questions yourself, that means that you have understood this lab very well. So I hope that you enjoyed this lab. Thank you very much.